Hello, this is Miss Goodwin, and today is Objective 5.1, Circle Properties and Theorems. The objective is that we can identify and describe the relationships among inscribed angles, radii, and chords in a circle. If you have not done the vocabulary yet, go ahead and go do that because the vocabulary is especially important for this unit. And we are going to start off by naming our angles and arcs. So here we have a circle, and we want to figure out how to name central angles, minor arcs, and major arcs. So they all kind of follow the same pattern. So let's look at central angles first. Our central angle is this right here. And really this convention goes for any angles, not just central angles. But we're going to pick one end to start with. Typically starts in alphabetical order, so in this case A, and then follow that angle through all the vertices or all the points. So A goes to O and then to B, and then we just label that or list those in order. So we have angle A, O, B, and like I said, that goes for any angle. Now let's look at our minor arc. Very similar. This would be our minor arc right here. We start at point A and then follow that to B. So in this case, our minor arc would be AB. Now, sometimes we'll want to differentiate that and figure out the major arc. The major arc is the bigger of the two. Notice they share the same endpoints, A and B. So in this case, we're going to have to include some outer point C to tell us we are looking at the major arc. So basically, just list all the points that you pass through when naming your angle or arc. Now that we know that, we're going to start looking at the central angle theorem. First, we're going to want to define what a central angle is. A central angle is an angle formed by two radii, which is the plural of radius, intersecting in the center of a circle, hence central angle. So that's going to be this angle right here. And we will name that, as angle AOB. Then we have our inscribed angle. The inscribed angle is an angle formed by two chords that intersect on the edge of a circle. So that would be angle ACB right here. So the central angle theorem states that the central angle from 2 points A and B is always twice the inscribed angle from those points. So there's two ways we could write this. So first, our central angle is AOB and our inscribed angle is ACB. So our inscribed angle AOB is equal to 2 times the inscribed angle. We can also write this, kind of flip it, so angle ACB is equal to 1/2 angle AOB. So those are two ways we we can state the central angle theorem. Now, any inscribed angles sharing the same arc AB are the same measure. So let's say we have, looking back here, angle ACB is already one of those inscribed angles. But let's say we place an angle here at D. That inscribed angle is the same measure as ACB. Same goes. If we put another one here, pretend that the endpoints line up. These angles all have the same measure. They might all be 35 degrees or whatever. So now that we've looked at the central angle theorem, let's take a look at some examples. So another note is that arcs and central angles are the same measure. So if one is 55 degrees, the other is going to be 55 degrees. Like this example, if angle AOB is 55 degrees, find the measure of arc AB, angle ACB, and arc ACB. So arc AB is this one right here, and that is going to be 55 degrees as well. Now we want to figure out the measure of angle ACB, which is this guy right here. And that's going to be 1/2 of 55 degrees, because inscribed angles are half of the central angle. So 1/2 of 55 is 27.5 degrees. And last but not least, we want to find our major arc ACB. Well, we know that the minor arc is 55 degrees, and all circles are 360 degrees around the center. So we just got to do 360 minus 55, which gives us 305 degrees. And we are done with that. So try this example yourself. Pause the video if you have to. Okay. So now we know that angle MPN, this one right here, is 105. We want to find MQN, arc MN, and arc MQN. So again, MQN is our inscribed angle, which means it's going to be 1/2 of 105, which gives us 52.5. You can do that in a calculator. Arc MN is going to be equal to that, so that is also 105 degrees. And then major arc MQN is going to be 360 minus 105. And that equals 255 degrees. So hopefully you got that right. Now let's recall a couple things from previous units. Vertical angles are angles that are across each other when lines are intersecting. And these are congruent. So like if this is 30, for example, this is also 30. If this is 60, this will be 60. We also have linear pairs, which are any two angles that can lay side by side and form a straight line. These are supplementary, which means that they add up to 180. So let's just look at a couple more examples of that. We have angle ROS. This one right here equals 105. Now we want to find ROQ, the angle ROQ and QOT. That's a lot of letters. But we are looking for this angle right here that I'm highlighting in green. Notice these form a straight line, which means they are a linear pair. So we can just do 180 minus 105, and that gives us 75. Which makes its corresponding arc, QR, equal to 75. Now we have measure of QOT, which is this angle right here. Notice it's a vertical angle to our original angle, which makes it 105. Now we are also looking for SR, this one right here. That is equal to 105. Now, this ain't on here, but I am going to show you how you would find multiple angles or multiple arcs being added together. So let's say we want to find the measure of TOS, but I want the big one. So let's say I want to find this angle. We know all three of these angles. We can add them all together. So that gives us 105 plus 75 plus 105. Oops. And that will equal 285. And you could do the same thing if you want the arcs. So if we want the measure of arc QS, that would be 75 plus 105. I keep forgetting the 1, but that equals 180. And ta-da. So go ahead, try this example on your own real quick. Okay. So we know that AEB is 27 degrees. We want to find BEC, so we do 180 minus 27. That gives us 351. That's 153. CED is a vertical angle, so that is going to be 27. Now we look at the arcs. AB is 27. That's this arc right here. And then AD, this one right here, is going to be 153. Now, one last note for inscribed and central angles. An inscribed angle in a semicircle, which is just one half of the circle, is always 90 degrees. It's always a right angle. And this line right here, AB, is the diameter. Now this is kind of a lengthy note set, so I'm going to pause right here, go ahead, quickly brief these, maybe do some practice, and then come back for the second part. Hope you have a wonderful day, and I'll see you in the next part. Bye!